Hello students, I hope you are able to see me and hear me. Is that the case? Just, just write in the chat box. Sorry. Am I audible properly? Uh, just a second. Chalo, ठीक है. So what we can do is we can, the topics that we covered today again are core number system topics. We'll try to touch upon the concept of cyclicity and the use of factorials. Now, factorials is a very common question in almost all examinations, whether it's an examination which is an overall level of difficulty easy exam or a difficult one. So obviously the level of the question will change, but topic wise certainly something that is very common in exams. Okay. Now you have to understand in number systems there will be patterns that will be formed and they will keep repeating because the number of numbers is fixed, right? And therefore, whenever you're tackling questions on number system, it is a good idea. If you're not able to comprehend what is happening, the values are big or they're complicated values, just imagine smaller values and see how they are behaving. Because numbers will behave similarly, right? So to start off, the concept of cyclicity. So what do you understand from when I say cyclicity of numbers? Cyclicity is obviously something that repeats, right? Why will cyclicity happen, or what is cyclicity? Now there is something that we refer to as decimal, right? What does decimal mean? Decimal means is my voice okay? So anyone can write in the chat whether I'm audible or not. अगर मेरे को सुनने में दिक्कत हो रही है तो चैट पे प्लीज लिखो. अगर सही सुनाई दे रहा है चैट पे लिखो. अगर सुनाई दे रहा है चैट पे लिख दो कि सुनाई दे रहा है प्लीज. मैं देख ले रहा हूँ. Yeah. So when I say what is decimal, what is decimal? The answer that pops into mind is वो डॉट जो हम लगाते हैं 35.57 बीच में dot is a decimal. But that is not the decimal per se. Decimal refers to the counting system that we use. Right? Why is it called decimal? For the simple reason that this counting system that we use has 10 digits, 0 to 9. Because I'm using a 10-digit system, 10 refers to deca. Deca means from deca I get the word decimal. There could be other counting systems as well. For example, a system which uses 2 digits, 0 and 1. These are digital systems. It is called binary. I could have a system which uses 8 digits, whatever, right? So in our system, we are using 10 digits to count 0 to 9. Because there is only 10 digits, if I repeat a mathematical operation, the digits are going to repeat for sure, right? For example, I say, I start adding 4 to itself, and I look at the unit digit. What will happen with the unit digit? I'll have 4, then 8, 4 plus 8, 22, 2 plus 4, 6, 6 plus 4, 0, and then 4 again. So if I look at the unit digits, then I repeatedly add 4 to itself. The digits that I get are 48260, 48260, and so on. Cyclicity is happening. This is the idea of cyclicity. We will try to find out the unit digit and the last 2 digit cyclicity of numbers that are given, typically powers. But to start off, some basic questions. What will be the last digit of 345 plus 361? 345 plus 361. Last digit will be, I mean, not very difficult to figure out. That the last digit will depend only on the last 2 digits. That is 5 plus 1, which will be 6. The last 2 digits are 427 minus 234. Again, will depend on 7 and 4 only. 7 minus 4 is 3. 434 minus 237. Now I have to subtract 7 from 4, which is not possible. So I carry forward, make it 14. 14 minus 7 will give me 7. 238 into 327. Again, just look at the last two digits. 8 sevens are 56. 3 into 3 into 3. 3 threes are 9. 9 to 27. 7 will be the last digit. What about 13 into 13 into 13? Again, the 1 does not matter because I am looking only at the last digit. It will be the same as 3 into 3 into 3. So it is easy to do, right? Unless I ask you what is the unit digit of 3 raised to power 45. So 3 is being multiplied by itself 45 times over. What will be the unit digit? Now is the question. So what we do is, we try to look for patterns. Very nice, Savanya. So we try to look for patterns. We are trying to find out the unit digit or the last digit as we raise the power of a number. So I'm making a table. What this table has is, I will write the digit n. The last digit of any number would be 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. We will look at the unit digit in each case. That is n raised to power 1, n raised to power 2, n raised to power 3, 4, 5 and 6. Hoping that we are able to see patterns repeat, right? So if you could quickly tell me, when the base is 2 or the base ends in 2, what will be the unit digits of the various powers? 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6. Just the last digit. Just write them down as a series. So for 2, what we'll have is 2. 2 squared is 4. 2 cube is 8. 2 raised to power 4, 8 into 2, 16. So 6 of 16. 6 into 2 is 12. So 2. 2 into 2 is 4. Now as you can see, I have 2 and 4. If I take this pattern forward, because I had 2 and 4 initially also, the pattern will repeat. So the unit digit of powers will be 2486. Then again 2486, then again 2486 and so on. What about 3? In the bias with a similar logic, what will be the unit digits of 3 raised to different powers? 3 raised to power 1 is 3. 3 square will be 3 into 3, 9. 3 cube will be 9 into 3, 27. So I write the 7. 7 into 3 will, because as I raise the power, I just have to multiply by n, right? So 7 into 3. 7 threes are 21. 1 threes are again 3. And 3 threes are 9. So basically the last 4, if I look at the last digit, again they are repeating after 4 powers. 3, 9, 7, 1. Again we get 3, 9, so the next digit will be 7, 1 and so on. We do the same exercise for 4. 4 raised to power 1 is 4. 4 square is 16. 6 into 4 is 24, so again 4. 4 into 4 is 16, so again 6. As you can see, 4, 6, 4, 6. So this pattern will repeat further. For 5, the good or the bad thing for 5 is 5 into 5 is 25. So if you keep multiplying 5 to itself, we will keep getting 5 only. What about 6? Again, 6 is similar to 5 in that sense. 6, 6 are 36. If I keep multiplying 6 by itself, I will keep getting a 6. Any power of 6 will end in 6. What about 7? 7 square, 49. 7 9s are 63, so 3. 7 3s are 21, so 1. 1 7s are 7, 7 7s are 49. So again, I have a 7 and 9 in the end. आगे भी 7 9 था, so pattern repeat हो जाएगा 7 9 3 1. फिर 8. 8 8 are 64. 8 4s are 32. 8 2s are 16. 6 8s are 48. 8 8 is 64. Again, 8 and 4 repeat. So 8 4 2 6, 8 4 2 6 will keep on repeating. Very quickly, tell me this series for 9 as well. Yeah, so 9 again is not that difficult. 9 raised to power 1 is 9. 9, absolutely. Very nice. 9 9 are 81, 9 1 9 1 9 1. So now if I look at the cyclicity of unit digits of power of every number, you will see that 2 repeats after 4 steps, 3 repeats after 4 steps, 7 repeats after 4 steps, 8 repeats after 4 steps. 2, 3, 7, 8. If I look at 4 and 9, they repeat after 2 steps. 5 and 6 always have the same. 0, 1, 5 and 6 always have the same number in the end. And therefore, what I can say is, anything that repeats after 2 steps will also repeat after 4 steps. But that is to say, I can either say 9 1 is repeating again and again, or I can say 9 1 9 1 is repeating again and again. So in general, the unit digit cyclicity of the powers of a number is taken as 4. So after powers of 4, the unit digits will always repeat. And therefore, if I am asked, what is the unit digit of 3 raised to power 45? If you can just give this a shot. The unit digit of 3 raised to power 45 will be. So 3 raised to power 1, 2, 3, 4 will have powers 3, 9, 7, 1. Then 3 raised to power 5, 6, 7, 8 will have the same powers. Very good, very good. So what I am saying is 3 raised to power 1, 2, 3, 4 will have unit digits 3, 9, 7 and 1. Again 3 raised to power 5, 6, 7, 8 will have the same unit digits. Then again 9, 10, 11, 12 will have the same unit digits. So basically, for every set of 4, the unit digit will repeat. So as power of 3 increases, the 3, 9, 7 and keep on repeating in groups of 4. So I take out groups of 4 from 45. The multiple of 4 less than 45 is 44. So if I remove those groups of 4, I will be left with 3 raised to power 1. So basically what I am saying is, the unit digit of 3 raised to power 45 will be the same as unit digit of 3 raised to power 1, which I can calculate orally is 3. What will be the unit digit of 13 raised to power 45 then? Unit digit of 13 raised to power 45. It will be the same as 3 raised to power 45 because this 1 will have no role to play in the unit digit. 13 into 13 also ends in 9, 169. 3 into 3 also ends in 9. As a matter of fact, 23 into 23, 529 also ends in 9. So the tens digit of any number will have no effect on the unit digit. So the standard formula, the standard rule becomes, if I have to find the unit digit of a raised to power b, I will divide b by 4 and find the remainder. The remainder could be 1, 2 or 3. If b is divisible by 4, I will take the remainder to be 4, not 0. So a raised to power b will have the same unit digit as a raised to power r. What is r? R is the remainder when b is divided by 4, and the values r can take are 1, 2, 3 and 4. R will be 4 when the remainder is 0. Where does this come into play? For example, if I say, what will be the unit digit of 18 raised to power 52? Unit digit of 18 raised to power 52. Here, if I divide by 4, 52 is actually divisible by 4. So the remainder will be 0. I will not say that this has the same digit as 18 raised to power 0, because that will then be 1. So what I do is I'll say, since the remainder is 0, so we look at 18 raised to power 4. So 18 raised to power 52 will have the same unit digit as 18 raised to power 4, which in turn will have the same unit digit as 8 raised to power 4. What is the unit digit of 8 raised to power 4? 8. 8 is 64. 8 4s are 32. 8 2s are 16. This becomes my answer. I think there is some. Okay. So, moving on. Now, let us try to increase the level of the question a little bit. What will be the unit digit of 17 raised to power 18 raised to power 19? So if I write it as 17 raised to power 18 raised to power 19 across a bracket. So this is essentially 17 raised to power 18 into 19. Right? So what I can do is I can calculate the unit digit here. 18 divided by 4 is a remainder of 2. So this will have a unit digit of 7 squared, which is 9. 9 raised to power 19. 19 by 4 is a unit digit of remainder of 3. So 9 raised to power 3, which will end in 1. 9199. Right? But this is not equal to 17 raised to power 18 raised to power 19. This and this are different. I am not multiplying the powers. I am raising the power of the power. Right? What will happen in this case? 17 raised to power 18, and then that power is again raised to power 19. So basically, I have to divide the power by 4, was my rule, right? Now, if I divide the power by 4, that is, if 18 raised to power 19 is divided by 4, will this division happen? Basically, I have 18 written many times. Multiply, divide by 4, 9, 2. The division is happening. 18 raised to power 19 is divisible by 4. So in this case, when I divide the remainder by 4, I get the remainder as 0. So this will have the same unit digit as 17 raised to power 4 or 7 raised to power 4. That is the question. But the point is, we haven't done remainders yet, right? So how will I solve for different types of questions? Well, there are 5 cases possible in this type of a question. I will just list down the cases. You can replicate the cases in exam by thinking of small values, and that should do it. So the first case that is possible is A is the base raised to the power 4k plus 1 raised to the power even or an odd number. That is to say 7 raised to power 5 raised to power 2 or 7 raised to power 5 raised to power 3. 7 raised to power 4k plus 1. So the first power divided by 4 leaves the remainder of 1 raised to power 2 or 5 raised to power 3. You will see that in both cases 5 square is 25 divided by 4, remainder is 1. 5 cube is 125 divided by 4, remainder is 1. So whether it is 4k plus 1 raised to power even or 4k plus 1 raised to power odd, both cases the remainder when divided by 4 will be 1. Therefore, for any number of the form A raised to power 4k plus 1 raised to power even or odd, the unit digit will be the same as a raised to power 1. When we do remainders, this will become more obvious, or we will get a better reasoning for why this happens. But for now, all I'm saying is, I look at the first part of the base and I choose a value for the second part. I choose small numbers and I see what is happening. That will happen with large numbers as well. So if I say, what will be the unit digit of 12 raised to power 13 raised to power 14. Now 12 is my base A. If I divide 13 by 4, I get the number as remainder as 1. So it is 4k plus 1 and even 14 is even. A raised to power 4 plus 1, this ends in A raised to power 1 or 12 raised to power 1, which is 2. This becomes my answer. Right? Without any exception, we can keep doing this. Absolutely. Yes, you're correct. अब देखो, अगर यहाँ पे मैं ऊपर और numbers लिखूं, does my answer change? Does my answer change? It does not, because since this is even, this entire thing also will be even. Right? So I just have to check for the base, the first part and the second part. उसके ऊपर कुछ भी लिख दो, आंसर में फर्क नहीं पड़ता. The second case, a raised to power 4k plus 2 raised to power even or odd. Again, I think of a small number. A raised to power 4k plus 2. Suppose question was 7 raised to power. I need a number which leaves a remainder of 2 and divided by 4. So 6. Suppose 7 raised to power 6 raised to power 2 होता, या फिर 7 raised to power 6 raised to power 3 होता. 6 square is 36. 36 is divisible by 4, so 7 raised to power 4 बन गया. 6 cube is 216. 216 is also divisible by 4, so ये भी 7 raised to power 4 बन गया. So a raised to power 4k plus 2 raised to power either even or odd is the same as a raised to power 4. And therefore, if I ask you what will be the unit digit of just a second. 43 raised to power 46 raised to power 49. Unit digit of this number will be 43 raised to power 46 raised to power 49. Absolutely. So the base has 3. 4k, this is 4k plus 2 and raised to power odd. So this will be the same as 3 raised to power 4, which ends in 1. Very nice. So far, in the first two, the second power, whether even or not, gave the same answer. When the first power is 4k plus 3, I get two different cases. A raised to power 4k plus 3 raised to power even. Okay, so 7 4k plus 3 means I need a number which is divided by 4 leaves a remainder of 3. 7 ही होता है. 7 raised to power 7 is even square. 7 raised to power 49. 49 by 4 is a remainder of 1. So 7 a raised to power 4k plus 3 raised to power and even number gives me the answer as a raised to power 3. A raised to power 1. Instead, if I have a raised to power 4k plus a raised to power odd. Okay, let me try this as well. 7 4k plus 3 7 raised to power odd cube. 7 raised to power 3 4 3 343 divided by 4 is the remainder of 3. And therefore, a raised to power 4k plus 3 raised to power odd is equal to a raised to power 3. Again, when you are trying to replicate this for yourself in the exam, I don't expect you to remember it and go in the exam. You just have to know what the principle is. There, you just write a small number and check for yourself what is happening. A raised to power 4k raised to power even or odd, if you can just assume small numbers and tell me what will this be equivalent to. Will this be a raised to power 1, 2, 3 or 4? Just think of small numbers, divide by 4 and see what is happening. I am dividing the powers 1 up part by 4, not the base. And I am taking a base which has 4 different values possible. Anyone who can generalize this and tell me. We have an answer, and that is correct. Very good. We have 2 answers. Very nice. A raised to power 4. Perfect. So here, I am saying 7. 4k means a multiple of 4. 4 or iska square. So this is 7 raised to power 16 divisible by 4. If I say 7, 4 cube, since the power is 4, it has to be divisible by 4. Another answer we are getting is also correct. So a raised to power 4k raised to power even or odd ends in a raised to power 4. इससे बड़ा क्वेश्चन यूनिट डिजिट साइक्लिसिटी में नहीं आ सकता, है ना? And therefore, moving on to 2-digit cyclicity. Questions on 2-digit cyclicities are rarer, and we will just cover the type of questions that we need. I mean, there have been questions on 1, 5, etc. We'll majorly touch upon them. And again, since we're trying to complete a topic, at least you should know what to do. Now here it says, what is the last 2 digits of 17 raised to power 18? When I'm looking at the last digit, 7 raised to power 18, 17 raised to power 18, 27 raised to power 18, all of them have the same number. But when we look at the last 2 digits, that will not be the case. Here it says, what is the last 2 digits of 17 raised to power 18? Anyone or students watching right now who know what binomial expansion is? Binomial expansion. You can use binomial expansion to solve this question, but I will refrain from that and I'll try to generalize a few cases for you. Okay. So the first type of question could be for a number ending in 1. Right? For example, if there is a number which is ABC1 raised to the power XYZ. ठीक, इसका मुझे पूछे यूनिट डिजिट बता दो. So what I have, sorry, इसके last 2 digits बताने हैं. So what I will do is I will take the C, that is the tens place digit of the base, multiplied by Z, the unit digit of the power. ये यहां से लेके इसमें मल्टीप्लाई किया. C into Z का जो भी यूनिट डिजिट आएगा, that followed by 1 becomes the answer. Right? I'll write an example which will make it clear. 171 raised to power 18, for example. 171 raised to power 18. We have to find the last 2 digits. So the last digit always will be 1 because the number ends in 1. Then I multiply 7 and 8. The tens place digit of the base, the unit digit of the power. 7 into 8 is 56. I take this 6, write it here. This becomes my answer. The last 2 digits of 171 raised to power 18, a number ending in 1, is 61. Again, for any number ending in 1, this can be done without any exception. Similarly, for numbers ending in 5, A, B, C, 5 raised to power x, y, z. Again, I multiply C and Z, the tens place digit of the base with the ones place digit of the power. This product will either be even or odd. If the product is even, the number ends in 25. If the product is odd, the number ends in 75. For numbers ending in 5 without any exception. For example, 3175. I'm adding extra numbers here. 418. Number ends in 5. I have to find the last two digits. 7 into 8. 56. 56 is even. Since it is even, this number will end in 25. Instead, if this were 3175 raised to power 417, 7 into 7, 49, odd. So the last two digits here will be 75. Right? Again, for numbers ending in 5, without any exception. So these two become my base rules. Using this, I look for the other set of numbers. Suppose the numbers end in 3, 7 or 9. Now, I know that 3 raised to power 4 is 81. 7 raised to power 4 is 2401. And 9 square is 81. So if I have a number which ends in 3, 7 or 9, I can raise the power of that number in such a way that it becomes a number ending in 1. Number ending in 1 का rule हमको पहले पता है, हम उस rule को apply कर देंगे. For example, if I say, what are the last two digits of 19 raised to power 24? अब 19 के end में 9 आता है. 9 का rule मेरे को पता नहीं है, मुझे 9 का 1 बनाना पड़ेगा. So I say 9 square is 81. So what I do is, for 19 raised to power 24, I want to square this first. So I say 19 squared. If I take 2 inside the bracket, 24 by 2, 12 is left outside. Now I find out the square of 19. 19 square is 361. I am just writing 61 because 3 is not important for me in this case. 61 raised to power 12. So now the number becomes something that ends in 1. So I multiply 6 and 2. 6 2s are 12. Take that 2 and the 1. So this will end in 21. Again, unit digit cyclicity important. Answers which end in 0, 1, they are the kind of question that I have come across. These are questions that at least I have not come across in too many questions. Here and there they might have been asked, but not very common questions. And therefore, I just want you to try one question. See, if it was 19 raised to power 25, if it were 19 raised to power 25, now I cannot take out the square from here. So I will write it as 19 into 19 raised to power 24. For this, we calculated the last two digits as 21 or something. Then I will multiply these two to get the final answer. $99 will be the last two digits. So what I want you to do is just one thing. I want you to find out the last two digits of 47 raised to power 48. again, I'm very candidly repeating that I do not expect this to be a standalone question, because it just tests your calculations with nothing else. Conceptually, if you know it is a very simple question. Multiplication करनी पड़ सकती है बस. But if I'm trying to close a topic, it's a good idea that I know it in entirety. कि इसमें क्या क्या possibility है सब बता. Yeah, 47 raised to 48. अब अगर number ending in 7 का रूल तो पता नहीं, मतलब 1 का रूल पता है. तो मैंने 7 की पावर चेक करी. 7 squared 49, 7 cube 343, 7 raised to 2. 7 raised to power 4 is 2401. So for 47 raised to power 48, what I'll do is 47 raised to power 48. I take the 4 inside. 48 by 4 is 12. Now I have to calculate the last two digits of 47 raised to power 4. So I calculate the last two digits of 47 squared, and then we'll multiply it by the last two digits of 47 squared, which will be the same. 47 into 47 ends in 7 7 is 49, 9 carry forward 4. 7 4 is 28, 4 32. No need to write anything beyond this. I just need two digits. 4 7 is 28, 0 9. So this ends in 0 9. This will also end in 0 9. So the product will end in 81. So I have made one multiplication, the other multiplication. So this ends in 81 raised to power 12. 8 2s are 16. 61 becomes the answer. If it is practiced, very nice. Sanil actually came up with the answer of 61. Sanil got the answer of 61. It's very nice. So again, with a bit of practice, this won't even take too much time. So we can deal with numbers which end in 1, 3, 5, 6. Odd number तो सारे हो गए. For a number ending in 0, I don't have to think, because 20 raised to 100 is simply 0 0 0 in the end. What is left is even numbers which end in 2 4 6 8. So here what happens is we have a rule for pure powers of 2. I look for a pattern here. What is the value of 2 raised to power 10? What is the value of 2 raised to power 10? Yes. 2 raised to power 10 is 248. 16 to 64. 120, 24. It is 1024. So 2 raised to power 10 ends in 24. What will be the last two digits of 2 raised to power 20? 2 raised to power 20 will be 2 raised to power 10 into 2 raised to power 10. So this will end in 24 into 24. 24 into 24 is 576. 76. What will be the last two digits of 2 raised to power 30? 2 raised to power 10 into 2 raised to power 20. 2 raised to power 10 ends in 24. 2 raised to power 20 ends in 76. 76 into 24. 24. And therefore the pattern will repeat. So again, as I've been saying from the beginning, the idea is not to remember anything. The idea is to be able to replicate it, right? So even if I forget, it will take me maybe a minute to figure out in the exam that 2 raised to power 10 ends, odd powers of 2 raised to power 10. 2 raised to power 10, 2 raised to power 30 end in 24. And even powers or even multiples of 10 will end in 76. 24, 76, 24, 70, that pattern will repeat. We'll use this to answer questions. Suppose we have last two digits of 32. We have to find out the last two digits of 32 raised to power 24. So first I'll reduce 32 into 2 raised to power 5. So 32 raised to power 24 now becomes 2 raised to power 5. outside of bracket 24. So 2 raised to power 120. 2 raised to power 120 means 2 raised to power 10 into 12. 12 is even. 10 into even. 10 into even ends in 76. So the answer will be 76. Probably a better question would be 32 raised to power 25. 32 raised to power 25. So 2 raised to power 5 raised to power 25. So 2 raised to power 125. This is 2 raised to power 120 into 2 raised to power 5. I need the first term to be a power of 10 and a multiple of that. This is 2 raised to power 10 into even. 2 raised to power 5 we can calculate as 32. This ends in 76. And therefore the last two digits will be 76 into 32. 6 to 2, 1, 5, 18. So this will end in 32. Right? So for ending in 1, numbers ending in 1 and 5, we were multiplying C into Z. For numbers ending in 3, 7, 9, we converted them into 1. For even numbers, we look at 2 raised to power 10 into even being 76. 2 raised to power 10 into odd being 24. If at all you come across a question, this is 38 raised to power 120. So 38 is 2 raised to power 120, 19 raised to power 120. Find them separately and multiply. Again, this is just a calculation question, so I'm not getting into it. I know how to calculate. Methods I know. So I have a few questions for you, if you will just quickly try them. 4137 raised to power 753. We are trying to find the unit digit. 4137 raised to power 753. Quick answers. Unit digit means divide by 4. So I divide the power 753 by 4. The remainder is 1. Because we are looking at unit digit, 413 does not matter. The unit digit will be 7 raised to power 1, which is 7. Excellent, very nice. We have an answer. We have an answer on the screen. Try the second question. 222 raised to power 333 plus 333 raised to power 222. Answer. One. Alright. So again, I just take this 2. Divide the power by 4. Remainder is 1. We take the unit digit 3. Divide this by 4. The power is 2. The remainder is 2. How do you, by the way, check the remainder when we divide a number by 4? What is the divisibility test for 4? Divisibility test for 4 is the last 2 digits as a number. So when I'm dividing 333 by 4, I just divide the 33. For 222 by 4, I just divide the 22. So 2 raised to power 1 ends in 2. 3 square ends in 9. So this ends in 11 to 1. Perfect. Not 11 but 1. 53 raised to power 53 to 33 raised to power 33. 53 raised to power 53 into 33 raised to power 33. Answer? Good. So take this 3. Divide 53 by 4. Remainder 1. Take this 3. Divide 33 by 4. Remainder 1. 3 3s are 9. Done. The last question for this is the unit digit of 19 raised to power 19 raised to power 19 raised to power 19 up till infinity. Answer for this? Okay, we have one answer is 9. ये लास्ट वाले का आंसर बता रहे हो ना? Okay, so this is basically, this base becomes my A. If I look at this number and divide by 4, I get the remainder as 3. A raised to power 4k plus 3. And this is odd. Everything of this does not matter. Okay. 4k plus 3 raised to power odd. So if I had 7, 4k plus 3 is again 7, odd is cube. 7 raised to power 343. So this ends in 7 raised to power 3. So this will end in a raised to power 3. So this will have the same unit digit as 9 raised to power 3. 9 raised to power 3 is 9. 729 is 9. That becomes the answer. Of course, there's an easier way to look at this specific question. But what I'm saying is, from what we have done today, if I am asked the question, I'll be able to answer for sure. The second thing is, if you actually look at it, for a number ending in 9, there are only two possibilities of the unit digit, either 1 or 9. 9 raised to power 1 is 9, 9 square ends in 1, 9 cube is 9, 9 4 ends in 1. So for 9 raised to power odd ends in 9, 9 raised to power even ends in 1. This is 9 raised to power odd, so this will end in 9 like we have calculated. And since we did this today, if you could also calculate the unit digit for, okay, just one question we'll do out of these three. You have to calculate the unit digit of 24 raised to power 45. This will cover almost everything. This is the last two digits. This will cover every rule that we have done for the last two digits. The rule for 2, the rule for 3, the rule for 1. 24 raised to power 45. I'm giving you a couple of minutes to at least try what can happen, and then I start. But good, I think most of the questions I've asked today have been answered, which is always very motivating. So what I'm doing here is I'm saying 24 is for 45. It is an even number, but it is not a power of only 2. It has other numbers as well. So 24 is 8 into 3. Eight is 2 cube. 2 into 3 into 45 is 135. So this becomes 2 into 130 into 2 raised to power 5. I am holding it here. Now I work with 3 raised to power 45. 3 raised to power 4 is 81. So I write this as 3 into 3 raised to power 4. 11. So this becomes, now 2 raised to power 130 is 2 raised to power 130, 10 into 30 odd. So this will end in 24. 2 raised to power 5 is 32. 3 is 3. 3 raised to power 4 will be 81 raised to power 11. 8 ones are 8, so this will end in 81. Now I have to multiply all of this to get the answer. Okay, so we start with multiplying 24 and 32 for example. 24 into 32, again only write 2 digits because that is all that is needed. 48, 4 3s are 12. So this 2 ends in 68. 81 into 3 will end in 43. So 68 into 43. If 4 carry forward to say in 20. 136, 4. 4 into 32. This will end in 24. If I have not done a mistake, this should be the answer. And I think, yes, Advik has also got the same answer. Again, you cannot have a question which is lengthier than this as far as 2-digit cyclicity is concerned. So that was the idea of cyclicity. I think that will be all for today's session. We'll pick up the concept of factorials the next time we meet, right? So thank you very much. Do take care of yourself and enjoy the festivities. Bye-bye.